Hi everyone. Hi everyone. I think we're starting on our talks. Um, Looks like the mock interviews went really well. So our next speaker is our intern within the reading team at Wikimedia Foundation. She actually came to us from the Outreachy program. She'll tell her story, how she went from sales into data scientist. So that should be interesting. Welcome, Zarin.
Thank you. Hey everyone. So like Maria just said, I'm Zareen Faruqi and I'm a data analyst intern here at Wikimedia Foundation. First off, thanks everyone for joining us tonight. I know everyone here has been really excited about this event. Um, so from looking at the description of this event and preparing my talk, I figured most people here are going to be aspiring data scientists. So I kind of wanted to share my journey getting into data analytics and just offer some general advice that I've learned over the past year that will hopefully be helpful to some of you. So first of all, I just want to gauge the audience really quick. So if you're comfortable writing at least 10 lines of code in any programming language, can you just raise your hand? Like, it doesn't matter what language. Okay, so actually most of this crowd. Um, Next, can you raise your hand if you've ever read any of the Harry Potter books? Okay, still probably like 70% of you. Well, you guys are all in for a treat. We'll get to that. But so first off, so about a year ago, I was not in data analytics at all. I was actually working in sales for a software company, and before that, I was a sales engineer for an electrical manufacturer. But big gray boxes aren't really my thing, so I was both of those jobs were good, but I felt like I wasn't being challenged enough. I was just kind of bored with what I was doing. I knew I wanted to make a change and get more technical. So that's like a pretty loaded term, but to me, that meant a mix of programming and math and computer science. So I knew I wanted to do that, but I really had no idea where to even start. Um, so we have this really good project or issue right now where there's so many resources to get into analytics or data science, but it's really hard to even know where to begin if you don't already have an idea. So a year ago, I started looking into some boot camps, and I did a bunch of research. Um, and so I'm just going to share some things that I learned about boot camps and just some like advice, I guess. First of all, if you're looking at boot camps, I would just remember that boot camps are businesses at the end of the day. So I'm like not trying to discourage anybody from doing a boot camp, but it's just important to do your own research. If you're looking at any boot camp, I would also recommend that you find graduates of that program on like LinkedIn or Twitter or something and reach out to them and try to talk to them for like 10 minutes and just get their experience from them. um, I think if you're totally new to the technical world, boot camps can be a really good option because you have a schedule of things to learn and you have instructors and peers. And that makes it much easier than like totally just trying to figure this out on your own. Um, but one thing that I didn't like when I was looking at boot camps was there was this really rigid schedule of exactly the topics I had to learn in the exact order and like the resource I had to use to learn those. And that's just really not how I function. So that was something I didn't like about boot camps. So, like, what do you do now? Um, so what I did was a self-study for a few months. There's also a lot of online free resources for anybody trying to get into data science or data analytics. I have a couple resources that I use. I didn't use all of these, but I did use a few of these to learn fundamental technical topics. So basically what I did was I would spend a few weeks learning a technical topic. And then when I felt, somewhat comfortable with that topic, I started working on a project to reinforce what I just learned. The projects really varied in the technical scope of what work I was doing, but I think this is really, really, really important for anybody trying to get into this field for a couple of reasons. First off, you can share your work with the community. So anybody else that's going to be in your position a year later or 6 months later, or any time down after you can share what you've done and they can learn from you. But also, your future employers have access to these projects. So you can do a coding project, put it up on GitHub, write a blog post about it, and then when you're applying to a data science job or a data analytics job, you're not just telling them, like, yeah, I know Python, but just believe me. Obviously, like in the interview process, you probably will have to do a coding example, but you can actually show people your work. I think that's super, super important. But I'm going to go through 3 examples of how I used this process to work on a few projects that I worked on last year. So the first thing I wanted to learn when I knew I was going to get technical and get into data analytics was Python, which is like, you pretty much need to learn Python if you want to be in data science or data analytics. So I was fairly new to programming in general. So I read this really good introductory book called Learning with Python, How to Think Like a Computer Scientist. And it really just breaks down programming fundamentals. And while I was reading the book, I coded along with all the examples in a Jupyter notebook. And that's on my GitHub if you're interested. But I use that all the time as a cheat sheet now. So I have the book, but I'm not going to flip through the book to find like this one example of how to do something, but I go to this GitHub cheat sheet constantly. So I spent a few weeks just reading a couple Python books, learning the basics of Python, and then I wanted to do a project just to reinforce everything I learned. So I thought a lot about what I find really interesting and a data set that would be really fun for me to play with. And I did a text analysis of the Harry Potter series. So I wrote a bunch of natural language processing code from scratch to reinforce everything I learned. And there are a lot of natural language processing libraries available, but I chose not to use any of them because I wanted to learn how to do things the hard way. And I felt like using those libraries would kind of be cheating, and I wouldn't really be learning like the basics of writing these loops and everything that I had just read about. I also wanted to use an external API. I used some Amazon S3 storage, and I used the Google Charts visualization engine to create some of these graphics I'll show you. But really, what I did was I just picked a topic that I really was interested in because I'm a huge Harry Potter fan, and I knew I was going to hack on this for a lot of time, and I just wanted to come up with some really interesting insights that maybe other people haven't looked into. So I'm going to just share a couple graphs with you really quickly. First off, this looks at the number of total words in each book compared to the number of unique words. So the first thing that kind of stands out to me is that there's not nearly as many unique words in each book as there are total words. I think that's just typical in literature in general, so maybe that's not that surprising. But also, the number of total words increases up to the 5th book, which is the longest book. I have a couple of theories about this. It might be because as the series progresses, there's just new words and new characters and places introduced. It might be because the average audience age has increased. These books were released over 8 or 9 years, so the general audience age is increasing. So a 7-year-old isn't going to pick up a book that's really huge, probably. But next, this is a trigram graph. So a trigram is a series of 3 words that occur in the same sequence. So basically what this means is, so that blue line is the number of times that the words Harry and Ron, in that exact order, appeared in all the books. The red line is Harry and Hermione. The orange line is Ron and Hermione. So one thing to note is that this is saying that it's in that exact order. So the blue line isn't taking into account Ron and Harry. It's only counting Harry and Ron. So if you've read the Harry Potter books, like I was always wondering if Harry and Hermione were possibly going to date at some point. But interestingly enough, like doing this text analysis kind of predicts that maybe Ron and Hermione are gonna date and not Harry and Hermione. So like I thought that was just kind of fun. And then this is a custom graph I made in Keynote, which is like the PowerPoint for Mac. But so this is a relationship graph. So first off, you'll notice that the circles are characters and they're different sizes. So the size of the circle corresponds to the number of times that name shows up throughout the series. And I used the Wikidata API to pull the list of characters from Harry Potter programmatically instead of just like, hard coding it myself. So the size of the circles is the number of times that name appears. And you'll notice that there's, like Harry's in the center, but like let's look at the Harry and Snape relationship. So you'll notice that the line from Harry to Snape is really thin, but the line from Snape to Harry is really a thick, bold line. So the size of that line corresponds to the strength of the relationship. So what this means is, I looked at the number of times each of these characters appeared throughout all the series, throughout the entire books. And for calculating the relationship between Harry and Snape, every time Harry's name appears in the text, I looked 40 words before and 40 words after. And then I compared that to the number of times Harry's name appeared without Snape appearing within 40 words. So I'm just making the assumption that if those names appear within 40 words of each other, that means those characters are either physically in the same location or talking about each other, and that strengthens their relationship. But the reason why all the characters' relationship to Harry is much stronger than Harry's relationship to them is because the book takes it's from Harry's point of view. So he's pretty much in like almost every scene where all of the other characters aren't. So Harry and Snape, when Harry's around, Snape's only around for a small part of that. But when we're talking about Snape in the series, Harry's normally there. So yeah, this was just like a really, really fun analysis for me to do. I looked into the natural language processing libraries and some other text analytics libraries, and I didn't find any of them were doing any kind of like relationship analysis like this. So I think this is like a very custom project I worked on, but obviously it's not like scientific process of finding this relationship. It was just kind of me like hacking on this idea and trying to figure it out. But so another project I worked on, and the next thing that I wanted to learn after learning some Python fundamentals was some basic web development. And I also wanted to get a little bit into machine learning. So on the top here, I'm not going to go into each of these, but these are some of the tools I used for this next project. So what this next project was, I created a web application which showcases a machine learning algorithm called Word2Vec, and I built the entire front end and back end from scratch. That was kind of like the goal, figuring out how to do this. And this machine learning algorithm, it's called Word2Vec. What it does is it takes in a large amount of text. It takes that text and it breaks it into sentences. It takes each of those sentences and turns that sentence into a vector. and then it runs a cosine similarity to figure out which words are most similar. So that's like a really high level overview of this algorithm, and it definitely doesn't totally do it justice, but just so you guys know what I'm talking about. And part of my goal was to make this project interactive to the public. So I'm actually going to do a really quick demo of this project for you guys. Okay, so this is what the site looks like. Can somebody who's read the Harry Potter books just throw out a word at me that is in the series at least like 50 times? So just like a word that's pretty common. Gryffindor, okay. Okay. So this is what like I'm running in the back end. I'm running this machine learning algorithm that's going through all this text, and it's saying that according to like the parameters I tuned this model to, here are the most similar words to Gryffindor. So this kind of makes sense, right? Like the other three houses are on here. I'm not really sure why like 5 and 10 show up. Oh, okay, there you go. I didn't realize that. So the words are on the left. Yeah, 5 points to you. Um, and on the right is the value for cosine distance. So what this means, like on a high level, so cosine distance is from 0 to 1. The closer the number is to 1, the more my algorithm is saying that that is a similar word. So for some words that don't show up in the text a ton, the cosine similarity for like the last couple words isn't that high. So if it's like 0.5 or something, it's kind of saying like it's not really that similar, but it is still like one of the top 7 words. Does anybody have another word? I'll try. Wizard. Okay. Okay. Old, I guess. Which makes sense. Muggle's kind of the opposite, but maybe it's used similarly. But yeah, and so like if you enter a word that isn't in the book at all, like I'm just gonna enter my name, like I'm not a character in Harry Potter, it says it's not found. Um, so in the back end, what this is doing is when a user types in a word, I'm running this machine learning algorithm in the back end. It takes maybe 3 or 4 seconds to run, and it renders to the user these results, and then those results are saved to a SQLite database that I have running on my EC2 server. So then the next time somebody else comes to this site and puts in that same word, the results are served to the user much faster. So if you want, like, you guys can all play around with this, and if you find something really interesting, let me know. I like randomly try words all the time just to see what they are, but this was also like a really, really just fun project for me to work on, and I show like all my friends this, and they're like, "Oh, it's so cool!" So it's fun having a project that people who aren't data scientists or like data analysts can also enjoy and think is cool. But okay. How do I start the PowerPoint? Okay, cool, perfect, thanks. Okay, here's the demo. Okay, so I'm just gonna go through one more project really quickly. So the pandas data analysis library is obviously like the most common data analysis library in Python. So I definitely wanted to spend some time learning pandas. This dude whose picture I have on this slide is this guy that makes these really, really great Python tutorials, and they're on YouTube, and he has a website. So I watched like 9 hours of pandas tutorials that he put out, and they're really, really good, and I would recommend them. And then So also the Wikimedia Foundation releases a ton of open data that's really, really interesting to play around with. And if you're looking for some like cool open data to mess around with and learn, some data analysis skills, I would definitely recommend checking this out. So I used their clickstream data to work on this next project, and it's not another Harry Potter project. But I did this project in July of 2016, and I analyzed traffic to the US presidential candidates' Wikipedia pages. Um, and I looked at some like social media trends around the candidates as well. So to go into this, first off, this is a chart which shows the number of hits all of the candidates that were still running in March 2016 got to their Wikipedia pages. So this is like really, really crazy. Donald Trump got more than 10 times the number of hits to his Wikipedia page. And actually in 2016, the Donald Trump Wikipedia article was the most viewed English Wikipedia article. But I don't know, I just thought that was like crazy. But so this is a Sankey diagram, and what this is showing is incoming and outgoing traffic to Wikipedia pages. So the gray lines depict the volume of traffic between these articles or these nodes. So what this is saying is that the U.S. presidential election 2016 Wikipedia page um, didn't really drive that much traffic to these candidates. The Republican Party nominations or the Republican Party presidential primaries pages also didn't really drive all that much traffic. But once people got to Donald Trump or Bernie Sanders or Hillary Clinton's Wikipedia pages, the number one article that they clicked out of was to that candidate's significant other's page. So this is just like a really interesting find. Like people weren't clicking and learning more about their policies or like political stances or anything. They just wanted to learn about their personal lives. And also, one other thing I'm going to really note quickly about the number of hits to Donald Trump's page. There's been research done about Wikipedia page views and election results for the European elections a few years ago. And that research suggests that there's two reasons why voters go to like research political parties or candidates, and that's because one, that party or that candidate might be new, so they're just trying to like learn about that party or that candidate, or the voter's unhappy with their current choice, like, and they might become a swing voter. But hits to like a candidate's Wikipedia page doesn't mean endorsement or support. It just means like the general public wants to learn about this person. Maybe because he's not a politician, but I don't know. Also, so I looked at social media and the number of hits Google, Facebook, and Twitter sent to these candidates as well. You can see that Google sent a ton of traffic. It looks like Facebook and Twitter almost didn't send any traffic to Sanders or Clinton in March 2016, and they did, but that number was just so small compared to the number of traffic sent to Donald Trump that it doesn't even really show up in this. Um, but yeah, so those are just 3 projects I worked on. I hope you guys got some ideas of like random analytics projects you can work on, but I have just some general advice too. My first piece of advice is if you want to transition into data science or analytics or development or anything technical, find a technical mentor who can review your code or help you when you get stuck on a problem so you're not stuck on it for 3 days. This is really, really important and it really helped me. Also, if you don't have a technical mentor in mind, go to local meetups, which I mean, all of you guys are doing. But I met a bunch of people at meetups in Boston where I live last year, and I got their contact information, and then I asked them to go get coffee with me And almost everyone said yeah, and everyone was really happy to just offer advice. And this really, like, it's really, really beneficial. And then the last thing is work on projects. Like, that's definitely the best piece of advice. If you're trying to break into data analytics or data science, work on projects, share them, and like get more visibility to your projects. And like let your future employers see those projects and reinforce what you're learning with your projects. So really quickly, like I said, I'm a intern here at Wikimedia Foundation through the Outreachy program. So Outreachy is a program for women and underrepresented minorities in technology to connect them with open source projects. It's a really, really great organization. It's a really great program. And if any of you are looking to transition careers, it's like something you should look into. Um, in the future, so I have this quote: the more I learn, the more I realize how much I don't know, which I think is really true for data science and data analytics. There's just constantly things you can learn, and you have to be really, really comfortable teaching yourself new things. I think that's like one of the biggest parts of this field, is to be like really curious and really just like keep learning new topics. But basically, like, my plan is to spend some more time learning math and statistics. I feel like I didn't do a lot of projects with math or statistics last year, and hopefully get a full-time job in data analytics. But here's some contact information. I'm on Twitter, I'm on LinkedIn. If you guys found any of those projects interesting and want to create something like that of your own, all my projects are on GitHub. You can use my code and read my code and reuse it. I have really detailed blog posts that explain how I built everything. So if you want to do something similar, I recommend reading those posts because I go into a lot of detail. But I'm happy to take any questions, or if you want to connect with me, feel free to ask me anything, and I can obviously help out where I can. So thanks, everybody.
Thank you so much to Zareen for a really informative talk. So I hope it inspired a lot of you to try to figure out how to get into data science. So our next speaker is Bethany Simmons. Bethany is awesome. She's a data scientist at Betabrand, and she'll be talking to us all about how data science and fashion can interface. Wait, how data science and fashion fit.
Hello, everybody. Let's see. Excellent. So I'm glad that you guys made it here. So my talk is at the intersection of fashion and big data. And because, essentially I've been at Betabrand for the past year and have really uncovered how this is fashion and big data are actually a very natural combination. So essentially for this talk, here's the outline. Essentially, I'm just going to give you a brief intro, and there's a couple of takeaways that I just want you to remember about how Betabrand thinks about data and data science. One, we think that crowdfunding is actually a type of market research. We are continuously testing, and we also believe that data is our currency. So intro. Who am I? So again, my name is Bethany Simmons. I've actually been working at Betabrand now for a year. They're an e-commerce, essentially clothing company. We have a retail store in the Outer Mission, and I work about a mile away. But before I started at Betabrand, I worked in a startup specializing in using distributed machine learning to solve the world's most complex problems. That's essentially what was pitched to me when I started working there. And then I built mathematical models using deep learning to perform automatic image classification and object recognition. So essentially, I did indeed build models that could tell you that that image was a cat with a very high degree of certainty. So when I was there, really, I thought that what I imagined was I was sort of living in like the future, and I really thought that my software would be used for something like this. I imagined that I was building a brain for a cyborg so that it could come and, predict everything that it sees around it. But ultimately, after 2 years of building these models, we ended up working with women's shoes. So our first client was actually a company based out of Canada, and all of the software and the models that we built were used to help women find boots faster with the features that with the features that they really enjoyed. So um, so we were really software as a service. So essentially, we had this company hook up with our API, and essentially we sort of had a data exchange. They would give us the clicks, we would give them the images to serve to the consumers. However, it was really primarily a one-way relationship, and I just started to get a feel for the scale and the potential of how much data there really was on these websites. We were really only getting a very small number of clicks, and there were so many questions I had about the customers, like what else they wanted to buy besides women's boots, if they liked other essentially we didn't get that information. And so that really was what led me into Betabrand. So, so what is Betabrand? Betabrand is kind of an interesting place. Um, this is our motto. An evil multinational corporation has to start somewhere. For now, it's pants. So essentially, we're trying to take over the world with our pants. We are not, this is sort of one little aside, we are not beta brands, we are not beta brand, we are not camel case beta brand. It's kind of a big problem that we have. But what we actually are we're a crowdfunding platform where really we want to democratize fashion. And what that means is that anyone can submit an idea for pretty much anything from your shoes to bags to hats to purses. You can put it in our think tank where it gets voted on by our community, and then it ultimately could become part of our ready to wear collection. So, like I said, we're a crowdfunding platform. We want to be inclusive and open by asking people what do they want, and then we can actually manufacture it for them. So we're part of the whole process where we get the ideas, and then we actually build we have designers and sewers, and so we actually create the products and put it up for sale. But Beta Brand is really, we really try to be defined by our community. So who are the people that are coming and shopping on our site? Who are the people that are taking pictures of themselves in our photos? That's really who we're all about. We're our model citizens. And so that's really what we call our customers that wear our clothes and paste pictures of themselves online. And, this guy, he actually wrote us an email and was like, my wife just found out that I bought this gold disco top and she wants me to take it back. So what do you guys think about it? And we gave him the thumbs up. So, like I said, so we consider this crowdfunding as market research, and I want to talk a little bit more about that. And this really starts about like where the company was formed. And essentially, it was formed about 7 or 8 years ago by our CEO Chris, who asked the question of why does corduroy have to be vertical? So what you can see here is actually the pants that he created called quarter rounds, where you can see that the corduroy is actually vertical and not, or horizontal and not vertical. Very clever. So essentially, this is the way our process works. Someone comes up with an idea, a sketch is made, votes are collected, a single prototype is made, and then goes up for sale. And essentially, now this is where I come in because we're getting copious amounts of data at every step along the way. So once an idea gets submitted into our think tank, essentially we have a community now. Our database is, millions and growing. But essentially we have people voting, commenting, making suggestions, taking polls on the sketch. And not only that, you get a lot of information, not about just people that are engaging with the product, but you also get information from people who don't engage with it. So we get votes, and those votes are actually very interesting either because depending on who you are, the votes could actually be worth a lot or worth very little. A single prototype is made, so then we have the specs made. We have a design team that goes in, makes the garment where it gets photographed, and then finally goes up for sale. So along the step, every single step in this process, we're really capturing really reams and reams of data. And essentially the point is just to get faster from an idea being born to a prototype being made and then having it in, you being able to purchase and put it and, get it in your house. So, so yes, we will indeed make you a business suit onesie, which has been one of our popular products, if you have the right data. So this is just a very small snippet of the type of dashboarding that we do. We have, dashboards going across every sort of department in the company, but also for every web page that we're on, where you really get to see the traffic, who's voting on it, their age. These are actually not the statistics for the onesie, but you just get tons of information about who is voting, who is looking at these products. And these are a couple of items that are currently up for voting. That one, the Leave Me Alone sweater on the right, that's actually a really interesting product. That's a GIF, but it's not moving, which is, because it's a PDF. Well, that's actually a GIF, and it's really interesting because this product went really viral recently. So what you can do is you can put the zipper over the top, and so the girl just sits there and zips it up, and it's just gotten a bunch of press. So this product is really kind of blowing up right now. And then you can see we have a lot of interesting travel items. So this is like a travel blanket scarf where you can wear it and then take it on the airplane. And then here at the bottom, this is unicorn flip-flops that were created by one of my favorite engineers. So again, one of the things too is this crowdfunding process, as I said, is really market research. One of the things we can do is see, well, in this crowdfunding period, are there certain products that are behaving in ways that we think are really unexpected or very anomalous? And so essentially what I'm just showing you here is this one product called the Sassiest Pants, which actually was very recently, over the past couple of months, our most successful product ever launched in the crowdfunding. And it's actually really hard to see right here, but it had very its behavior in the crowdfunding. These are the cumulative sales. It had this really interesting step function right around day 50, and I'm still not entirely sure what exactly happened right there. This product was actually designed by a Project Runway alum, and I don't know if she was able to sort of advertise it on her site, but for some reason it just ended up getting a lot of sales. So essentially, these are the type of products that we're really looking for in some ways. We can take these things that really resonate with our database and then push it into ads so we can really start selling more. The other thing about Beta Brand is that we're always testing. And in this case, it's really all about A/B testing. So and it's sort of nice that our name is Beta Brand, but essentially what A/B testing is when you take an original and a variation of some type of experience, pit it in the real world, and see who wins. And so essentially we do extensive A/B testing of our site on pretty much anything you can imagine: button colors, copy. I mean, we run A/B tests on pretty much every component of our website, and we're constantly doing it. So these are just a couple of examples of some of the A/B testing that we did on our website. But what actually, this was for advertising. And so you can see right here, these are two different images that we had in ads. And you can see that this image right here with the thumb hole got a 20% lift in click-through rate. And essentially, once this was really uncovered, we literally had designers on our floor cutting thumb holes out of our garments that didn't even have that. This was a very interesting observation. And so most of our products do come with a thumb hole, and it's something that continues to be a really interesting success. And why this happens, we have a lot of theories. Actually, we'll get to another photo in in the future. This is another type of A/B testing. So this is sort of the experience when you come into our website. Um, so there's sort of a light box goes up, and we want to get your email address. And so you may not be able to really see here, but we have tested different copy, different colors, different backgrounds, whether or not you can click out of this or not. And so what's really surprising is that little tiny shifts can really improve the metrics that we're looking at. So here's another test that actually I was running. We were doing image gallery testing, and I wanted to see if there were certain images that really led people to convert. I kept the sequence of images the same, but just shifted the first image in the gallery. So what the test showed that actually this seat shot is the best image to have in our to increase our conversion rate. Here's another example, and I guess I sort of already gave it away, but this was actually an example from an email we sent out last week where we gave different images in the email, and what we found, I was actually a little surprised, although I shouldn't be, is that once again the thumb hole just annihilated the other two images. I'm not entirely sure, but people love thumb holes. They're confusing, they're weird. I'm not entirely sure, but why? I don't know. All we know is that this is a feature of our audience. So ultimately, this A/B testing allows us to quickly optimize our goals so that we can get people on the website doing what we want, if it's just adding to cart or checking out. One crucial thing is that our database is really changing over time. So this A/B testing has to be done all the time because our population is always changing. And again, we really have to test our assumptions about who we are. And finally, data is currency, and ultimately, you definitely need emoji support in whatever platform you're using. So this is just sort of another taste of the other side of the business because, yes, we have tons of really rich user information, but then there's tons of sort of business intelligence that we need to report on. So this is just actually sort of a small snippet of the type of dashboarding that we have at our business that everyone has access to, where you can really see like how much we're making, what the average order value is, a bunch of key business metrics that are really, really important, you'll find. This right here is sort of a fun plot that I generated, looking at how this was actually called a cohort analysis, where you look at a group of people. So for example, customers that first shopped with us in December of 2016, and then essentially you paint them in the same color and you can see how they continue shopping with us over time. And I don't know if you can see this, but essentially there's these big spikes in the data right here. And what that is essentially us training our customers to only shop during sales. So these are huge sales events right here, which is, something we're trying to minimize a bit. Another thing is, lots of data about our customers. So this was actually a plot that I gave to our CMO that convinced us to really put a lot more money and effort into our male customers. What here, these two plots represent lifetime value of customers, so essentially how much we can expect a new customer to generate for us over a year. And what you can see is that this bottom line is females, and so essentially a female customer has a lifetime value of about $175, although our male customers have a lifetime value of about 225. So there's just a lot of really interesting pieces of information you can get about the business. And then sort of another side is ad spend. So we put a lot of money into our ads, and we want to figure out what's working best. So you can see we have Facebook and Criteo and Google, and we really look at a bunch of these metrics to figure out what's working best for us. And finally, again, we have to look at website performance. So this really shows a bunch of different events that people can engage with on our site and how that's really trending over time. And then finally, we have tons of social media sort of partners. We have Instagram, Snapchat, really, taking all this data in and trying to figure out who are our best customers and how can we capture that information so that we can really make people loyal Beta Brand customers. So finally, part of the reason why this is really exciting for me is that fashion is really a multi-billion-dollar industry, and that's why there's tons of AI companies getting into it to try to make product recommendations, do forecasting. And Betabrand, really what they want to do is take away control from sort of the elite and put it into the hands of anyone with an idea. And usually with this, making a single prototype of an item, we can actually predict what the future sales are. So that's really exciting. And again, fashion analytics is really a very broad field, but it's becoming more and more sort of uh, trendy. I mean, you can think about Stitch Fix. I mean, they have hired, hundreds of data scientists, it seems like. But there's a lot of things that people can do with fashion. Is, what's the next big trend? How can you figure out fashion from social media, recommendation engines? There's really sort of limitless opportunities. And then finally, I just sort of wanted to show an interesting little tidbit of how Betabrand likes to stay on top of the trends, although now this is actually a little bit in the past. But what you can see right now is how emoji has just been increasing in popularity over time. And one of the products we made right at the peak of this was this poo emoji button-up shirt, which again was a really popular item. So anyhow, that's my talk. Thanks for listening. And I actually am hiring, so if you want to send me an email or resume at bethany@betabrand.com. All right, thanks.
Thank you so much, Bethany. That was super interesting. And thanks for all of you for coming here. I hope you learned something. We'll be posting at least one set of the slides, my slides, on the meetup page. And thank you to Wikimedia for hosting. And thank you to Maria for organizing such a great event.